Next, we have Professor Dr. Thomas Kolbe, who is Chair of Geoinformatics at TU Munich. His main research interests are in the fields of virtual 3D city, landscape and building information modelling. And Thomas is going to talk to us about interoperable digital 3D and 4D models in the urban environment. Thank you, Thomas.
Thank you very much. Let me just start my stopwatch to be in time. So, welcome to my presentation, which is about interoperable digital 3D, 4D models of the urban environment. And here is already some illustration what is meant by 4D and having basically dynamics being included, so that can be moving objects, but that can also be sensor data that is being acquired in the city. Actually, if the layout is looking a little bit weird, the original layout size was 4:3, and it's now being extended to 16:9. So that's something. I have so many old slides from many presentations before. They are all in 4:3. So basically, I'm just stuck at the moment with this layout. Anyway, so this is something that has been repeated already many times today, so I don't really have to repeat again. But I think there is one important aspect here, and that is basically we have the physical object, we have digital objects, and they are connected in a bidirectional way, and I think that's one of the key things. But when we talk about a physical object, then I mean, if you talk about a wind turbine, the wind turbine consists of parts. And the parts, again, consist of parts. So that means actually a digital twin is not that simple, because in the end it's something like a hierarchical thing, an aggregation hierarchy. And we can also have a look at the data modeling side. So for example, we can think about any complex object, might be real or might be digital. Of course, then it typically consists of many other types of components. So for example, a car consists of the wheels, but of course I will relate that now to the urban environment in a minute. But we have components again. So, and we have many more components. But then, however, of course, each component again consists of many more components, subcomponents. So, and that's basically, of course, one of the aspects that is, of course, also important when you look at a city, because the city is, of course, a complex environment, and it consists of many different parts. And the question is, how can we make a sensible separation of the city and the real space that is out there into some useful parts? And one idea is to say, okay, one type of objects that we have are buildings. So that means basically we see here on the one hand side we have the buildings, but then the buildings themselves are decomposed again, maybe into their components. And that can be walls, that can be roofs, but that can also be the solar panel on top of the building, and many other aspects. But of course, we also have other kinds of objects. So for example, we might have roads, which are part of the city. We might have water bodies. We might have every single tree, etc. So it basically means we have a lot of real-world things out there. And maybe also charging stations for electrical vehicles, for example. So, what we can observe is when we look outside at our city environment, we can say most relevant urban objects are physical things. So it means they are there, we can touch them, we can even measure them, and they occupy space in the real world. So what we can do is we can simply take the entire 3D space of the city and then take a sharp knife and basically cut them into small pieces. And now we can say that piece is representing that building, and the other piece of the space is occupying basically a tree, and the other part is that. So that means we have something like a continuous space, but however we can then come up in the end with discrete objects. And of course, every of those objects has spatial properties, like for example, where is it, what's the location, and the orientation, but of course also extent and shape. And so we can also think about that space is something like a unifying organizing principle for many kind of urban information, not for all urban information, but for many aspects of urban information. And then, of course, what we can do is we have sensors. We have remote sensing, for example, in order to, and photogrammetry, to record the spatial configuration. So we can have an airplane, we can have satellites, UAVs, vehicles, etc., all measuring our environment. And we also have more and more automatic extraction methods nowadays to automatically extract these objects that we are interested in from this kind of data. And this was also mentioned today. Of course, these kind of digital models, these kind of three-dimensional digital models, provide us with an intuitive visualization and exploration possibility. And it's very, very intuitive for humans, much more intuitive than 2D maps. So for example, if you look at a 2D development plan, it's very difficult for non-specialists to get an imagination how the real situation will look like once everything has been built that is drawn in that map. And this is, of course, much easier and much more transparent to be visible from 3D views. Now, when it comes to digital models of the city, the question is, can we get away with one model? And the answer is no. So basically, and we will never be able to get away with one type of digital model. And this is also one of the reasons why I love this term, digital twins, because it makes clear there is not a single model, but in the end, typically, the urban digital twin consists of a huge amount of different models, which are all having different specialities, and they are also typically focused for specific purposes. But in the end, we will always have to deal with a multitude of digital models, because all of them have certain strengths, and certain weaknesses. And what you can already learn is that many cities nowadays are using all these kind of models at the same time. Of course, this raises questions on data integrity and consistency, which is, of course, a big issue. Nevertheless, for example, the bottom left, 3D mesh models, that's basically everybody of you maybe who has looked at Google Maps 3D. When you see the nice 3D visualizations, that's just a mesh. And so in the end, everything is just a triangle and a bit of texture mapped on it, so it looks very realistic, but it's basically no information about what do you see? Do you see a parked car? Do you see a tree or a building? What kind of building, etc.? All this information is not in these mesh models. So nice for visualization, but not really useful for many kinds of analytical tasks. 3D point clouds, that's also something that can be very quickly generated either by laser scanners, but also by photogrammetric methods. And these two, the bottom line, they are so popular because they can be generated so cheap and so fast. So it means you can really send out a drone, fly around the building, and then maybe 10 minutes later you have the point cloud of this building. But and from the point cloud you can typically also generate the 3D mesh model. So that's also quite simple. But then the top line, these are the data sets with a high value basically, and these are called semantic models. Because there, every object of interest is represented by an individual object. And these objects have identifiers, object IDs. They also have not just the geometrical properties, but they also have thematic properties. And also they have relationships between the objects. So that's something, and so there we see two different representations, and I will quickly talk a little bit more about these two. So, and this is basically the idea of spatio-semantic modeling. And so what basically you will do is we make a 3D decomposition of urban space, but into meaningful objects. So we are not doing this arbitrarily, but we are really saying, okay, we're interested in buildings, so let's try to identify the buildings and also separate neighbored buildings from each other. So it's not just if you, for example, have one large building block with many separate logically separated buildings, then you should also in your city model make that logical separation into the object or down to the object level. So I will talk about that why in one of the next slides. But of course we don't have only the buildings, but we also have roads, we have railways, terrain, water bodies, vegetation, bridges, tunnels. We also have the utility infrastructure, so there are many different aspects which are basically addressing this. But of course, one object is not just monolithic. So a building, if we have a closer look at buildings, the buildings again are decomposed into further parts. And those parts again might be further decomposed. But the same is true for bridges, for building, for tunnels, but also for vegetation. So we can possibly go down even regarding the building, down to the level of apartments and single rooms. This is of course done in BIM, but if you also come more from the side that you are not having a BIM model because you're planning to create a building, but you have the existing reality, then basically it's more like going from the small scale model, so with few details, down to the very large scale model, which is then having a lot of details. And what you can now do is you can attach domain-specific data. And I think this was shown in the presentation before by basically linking all these kind of data. But in order to do that, your objects must be defined in a sensible way. And this is shown here and illustrated. I mean, this is not such a nice detailed building model, but the interesting fact is this building is synchronized with the cadaster. So it means it also honors the property boundaries. And for example, in Germany, we have that kind of representation for all 58 million buildings in Germany. So, and that's basically every of those 3D models is completely synchronized with the boundaries of properties. So that means even if we have row houses, every single row house is represented separately from each other. And that, of course, is quite useful because every typically separate building has its own postal address. You also have different owners, and every owner can decide whether to renovate his part of the building or not. And so, I mean, this kind of alignment of the data alignment is quite important. If you have that, then you can, of course, also link very easily and in a unique way different other thematic data. For example, energy-related data. You can have noise-related data, but maybe also economically related data. And this kind of linking only works if these kind of objects are modeled in a stable way and also maintained in a stable way. And having, for example, unique object identifiers is something that is very, very useful in this context. And if such kind of models are being maintained by a mapping agency, typically this is being ensured. And now we can also have a look at these different approaches, you could say, because on the one hand side, we have, maybe you have already learned quite much, also heard about today in the other sessions, on BIM, Building Information Modeling, and that's basically typically addressing the representation of the reality on the scale of individual sites. And on the other side, we have basically semantic 3D city models, which is basically addressing a more generalized view, but then a complete view, basically including all the buildings and all the other objects in a specific city, maybe even up to an entire country. And this slide was, or this figure was shown by Jantin this morning already. So basically, it also shows that BIM and maybe approaches from the GIS domain are quite different from each other. And it also makes sense because when you want to generate a building model for a building that has been already created, look around you here. Are you able in this room to really tell me where the slab is or where the wall is? I mean, there are a lot of claddings before, and the only thing that you can measure with a laser scanner or with observations is basically the surface. So the question is the IFC data model, for example, really the right data model to represent buildings that are already built? So this question you should really ask yourself, because if you create an IFC model, I think there will be a lot of decisions that you have to make. Many of them will be wrong. So it basically means you will have a model in the end that has some details where people can possibly use it, but we will make some wrong implications about it. For example, let's have a look at this beam. You see this beam, and I mean, the only thing that you can observe is basically a piece of the beam in one room and a piece of the beam in the other room. Whether the beam is really going through, you don't know, actually. And if you assume that this beam is going through, but it isn't, and you will tear down that wall, maybe even the entire slab crumbles. So that's basically something you should really be aware of. Okay, so in the end, that kind of model is, on the left side, is much more supported to support design process, to create models for planned objects. On the other side, it's more the kind of approach that is more suitable to describe objects from observations. So that's basically also here a different approach. Now I'm talking about interoperability, and I mentioned already IFC, but I will now focus more on the city level side, and that's basically, there is a standard that is called CityGML. And if now every city would basically come up with their own idea how to separate the objects into pieces, etc., then of course, for the city, the problems might all be solved. But that means if you develop a tool which is doing systematic analysis, maybe, for example, energetic applications, then maybe this tool is not transferable to the neighbor city and to the other city or something. And if you want to make sure that in the end you have a market where tools are being created that can be used in Singapore, that can be used in Tokyo and in Hamburg and in other places, so basically you need to come up with this kind of interoperability level. And all these cities which are mentioned here are modeling their city models, for example, according to the CityGML standard. And in the CityGML, you can basically map the state of the city at a specific time. But you can also, of course, use that kind of model as a starting point for doing some kind of what-if scenarios. So, of course, CityGML can also be used to represent objects that are not there, or that are basically modified according to some planned action, for example. So that is allowed, and that's possible. And then, of course, you can run a number of many different kinds of use cases and applications which can run on the same virtual representation of your environment. And so, for example, energy demand and production estimation, noise emission simulation, but also real estate management, urban facility management, things like that. Maybe some more words about CityGML, especially the new version. So first of all, I mentioned this, it's a standard that is issued by the Open Geospatial Consortium. And what is really, really important, which point I would like to make here, CityGML is not in the first hand an exchange format. It's in the first hand a conceptual model, how to subdivide the city into logical pieces, into components, what are important information attributes, what are relationships, and then in the second stage, CityGML is mapped to an exchange format. So it's also an exchange format, but in the first place, it's rather the question, how should you structure your information about the real world? So, and it represents geometry, topology, semantics, and appearance in 5 different levels of detail. And the new version, version 3, for the conceptual model, it has been released 2 years ago, and this year we had then also the release of the GML-based encoding of CityGML. And what is maybe interesting is that there are alternative encodings nowadays for CityGML available. So, for example, not just the mapping onto GML or an XML-based exchange format, but for example also to a spatial database management system. But we have also heard about Onto CityGML or mapping to OWL and RDF framework. So that's also available. But also from TU Delft, they have developed this CityJSON encoding basically for the CityGML standard. So this is also something that is available. Let me just quickly show you a little bit about the standard and what is being included in this kind of standardized representation. On the bottom right line, you see basically all the thematic modules. So these are the different topics, you could say. So like how to represent water bodies, vegetation, transportation. And transportation really means the street space, but also railways, but also waterways. They are included in there. So you can also use this to represent, for example, the canals in Amsterdam, for example. Relief is the terrain model mostly, land use and land classification. Then we have city furnitures. City furnitures are things like park benches, but also traffic lights and traffic signs. They could be also considered as city furniture. And then we have the broad field of construction where we have buildings, bridges, and tunnels. And above, however, we have some modules which are applied to basically everything. And so what is maybe interesting is we have 4 new modules, however 3 of those cross-cutting modules. And I start with a point cloud. Point cloud now allows that basically you can say I have a building and the geometry of the building is just represented by that point cloud. And so this is now possible also in CityGML, so you can simply say I just have a point cloud representation for this object. But I think the 2 others, they are very, very important for, especially for the digital twins, because versioning, the versioning module is as powerful as Git. So if you know how to work with Git or GitHub, then basically this entire complexity is now mapped or available in CityGML datasets. And that means in one single city model dataset, you can include the full history of the city model and exchange that even in one file if you want. But it also allows you to model versions, so you can also have alternative versions, they can merge again. So that means in the end, the data model, the conceptual data model has been extended. And it supports bi-temporal timestamps, so you have 2 different kinds of timestamp. One is database time and one is real-world time. So you can say, you can answer questions, how was my city model looking like at a specific date? And the other possibility is how was the world looking like at a specific date? This is quite important to distinguish, because if you want to know maybe why a certain decision has been made for urban planning, then of course the knowledge that everybody had by that time was key for the decision, not how reality was like, but basically what was their knowledge. And that refers to the question, when was some data included in the city model and not? If you, however, want to know what was reality looking like at a specific point in time, then you can also search and ask for these kind of things. So versioning is very, very important to really feed this idea of a cumulative documentation about the real world environment. And then we have the dynamizers, and I will come to that in a minute. The transportation module was substantially improved. I have maybe just a short screenshot later on. And the building module was also improved. So for example, now in CityGML you can model stories. You can also model apartments and other kinds of building subdivisions, also logical building subdivisions, if you want. Okay. This is just illustrating the idea how CityGML basically works. This is the data model, and it simply says everything in the city is a city object in principle, and the city model consists of a number of city objects. And every city object, however, can also have pointers to external references. So for example, you can say one building is also represented by that BIM model, for example, and this kind of reference could be also included here. Then you can say, okay, we have sites, and below sites we have the buildings, but also tunnels, for example. Then we have transportation objects, relief features, water bodies, and all of them can have different geometries for different levels of detail. So this is also something that is consistent. We have introduced a new concept in CityGML version 3, and that's basically a space concept. And that was basically the idea to simply say, okay, when we look at the urban space, we can basically say everything in the real world that is of interest to us is either occupying space, so it's volumetric in its extent, or it's either maybe building the boundary between two other volumetric things. Just as an example, the terrain model. So the terrain model typically is a surface, and that's just the boundary between the ground space and the airspace. So that's basically what the terrain model is. On the other side, you can say the building is occupying space in the real world. And if you think about a road, the road is not just everything that is being constructed, but of course, if traffic should happen, it needs space. So you need to have free space where cars can navigate, where pedestrians can navigate, etc. So in the end, we reformulated every CityGML concept from the earlier version to use these kind of base classes in the end. And so we could basically say, okay, we have something like an abstract space that is bounded by space boundaries. The interesting fact is, in CityGML, you can even model a data set without geometry. So you can, if you just have a building repository or a set of data sets about buildings, you can just also use them. You know the building is in real world occupying space, but maybe you don't have a geometry at the moment, so that's also fine. So you can also use CityGML for that purpose. And then the spaces are further subdivided into logical spaces and physical spaces. Physical spaces are those which are bounded by some physical constraints. So maybe this room is bound by walls, by the floor, by the ceiling. So that's basically a physical space. And then for the physical space, we can even subdivide them and saying, is it an occupied space or mostly occupied or mostly unoccupied space? And in order to illustrate that, maybe here's just an illustration and say the road is mostly unoccupied. There may be cars, there may be some traffic signs in there, but mostly it's in the first hand it's unoccupied. And on the other side, the building, if you fly over the building, typically all that space is occupied. You cannot basically let a road go through that building. But of course, if you have a closer look, you see the building might have rooms. Or typically buildings have rooms. So that means there are unoccupied spaces inside the occupied one. And then, however, even inside the room, you may have furniture, and the furniture again is occupied space. So you can also have this kind of nesting between occupied and unoccupied spaces. Okay, and this helps you in the end in reasoning. So if you want to make, for example, a navigation which works seamlessly between indoor and outdoor, you don't have to look for roads and you don't have to look for buildings. You simply find all those navigable spaces, all those free spaces which are topologically connected. In principle, basically a car or a pedestrian can basically travel along these lines. And now this is basically what I mentioned with the dynamizers. We need to think about, especially for digital twins, that we have high dynamic data, and which basically changes in milliseconds, for example. So for example, we have variations of spatial properties. So for example, if we have moving objects, but we also have thematic attributes like, for example, energy demands, temperature, solar irradiation, energy consumption. These are all properties. I can say that the energy consumption of a building is a property of a building. I mean, that's a characteristic. And it changes, however, every millisecond. So these variations can be with respect to sensor data or near real-time data, but it can also be the result of a simulation, for example. And so the idea in this CityGML Dynamizer module is, on the one hand side, we have all these different kinds of 3D objects with their spatial properties, with their thematic properties, with their appearance properties. And on the other side, we have all kinds of sensors, and that can be in situ measurement, like smart meters, or, for example, temperature measurements, environmental monitoring, or we can also have remote sensing data sets. But we can also have maybe tabulated time series data as a result from a simulation, for example. So the simulation gives you a time series about maybe temperature variations or whatever. And now the idea is basically we connect them. So we simply say, okay, one specific object, for example, that building, it has a property called energy consumption. But that energy consumption is not stored in the CityGML file, but it is provided by one specific smart meter. So that allows you in the city model to make an explicit link between an individual object property and some time series data that is maybe stored somewhere else. It also has not to be represented inside the CityGML file, but we basically allow you to make these explicit links. And this is just a use case example where we did a solar irradiation analysis for every single surface in a city model. And so basically now you can click on an arbitrary surface and you get basically these estimated values. That's a very simple use case for this. I mentioned the street space modeling example, and here you can see how much details we can now represent and distinguish, also semantically distinguish. This is not just computer graphic. Basically, every of those pieces of the city, of the street space, know that this is a bicycle lane, that this is a road marking, this is a road marking. We know where there are the traffic lights. We also know every individual driving lane is modeled separately as an object. And of course, this kind of data is required when you want to do driving simulations, traffic simulations, also when you want to work with autonomous driving. We're doing currently a research project together with Audi, and the automotive industry is also using a special kind of data format that's called Open Drive, which is being used, and we have developed an open source tool which you can download and use that can convert Open Drive data to that kind of representation here. Okay, CityGML is currently being in use worldwide, and there are even several countries where basically basing their 3D model on this, and for example, Germany and the Netherlands. And we heard about the Netherlands this morning from Jan Tien. But also Japan. So for example, Japan has now released as open data for more than 100 cities, the city models, and you can freely download them as CityGML files. And this includes Tokyo and many other cities, which is quite interesting. There is even a list of open CityGML datasets, which you can find here on GitHub. And CityGML also allows you to extend the data model by specific application domains. And one is called Energy Application Domain Extension. The other one is Noise Application Domain Extension, and they are also being used internationally. Okay, I'm nearly approaching the end. This is just a more high-resolution visualization, and what you now see is basically the result of a visualization of the results of a traffic simulation. So basically, Zumo was being used as a tool to do the traffic simulation, and however now everything that is moving and everything that's playing a role in this simulation has now been exported and jointly being visualized now using the Cesium browser. And this allows you also to stop the time. I cannot do it now because it's just a movie, but you can also go forward and backward in time, and it will also adjust the positions of the cars according where your time slider currently is. We are already working on also integrating the current traffic lights, so that basically if you move forward, you can also see when which traffic light switching to red and green, but also other kinds of sensors to also integrate that in that kind of a visualization. Here's generally an idea of many kinds of simulations that you can do. We are collaborating here together also with some companies from Germany, like Virtual City Systems or CADFIM. We're basically mostly using ANSYS software for this kind of simulation. But the nice thing is, for all of these different kinds of applications, direct pathways from a CityGML model into these simulations have been already exercised and being implemented. So there are already workflows for these things. So coming to the end. First of all, I hope it became clear that if we want to tackle these urban challenges, we often need a comprehensive digital spatial representation of the environment. So this is really often one of the key components. The digital model is not the digital twin. It's just an important component, I would say. But there are different types of city models, and we will never be able in the end to have the one model that basically rules them all. That will never happen. So we will always live with the different representations. Still, however, linking these different representations of the same real-world object is still a challenge. And if you, for example, have a BIM model and maybe a point cloud and you just want to know which one is, are they really the same? Are they representing the same real-world object? It's very, very difficult to automatically assess that. So we are doing some research on it, but it's still an open problem. And semantic modeling is important. So you can use computer graphics for visualization, and that's really nice. But as soon as you want to do more analytics, analyzing buildings, for example, for energy demand, but also analyzing the street traffic, etc., you have to have this kind of semantic information about the real world. And finally, the CityGML standard is an international standard of the OGC that is useful in this context, I would say. It is a geospatial information model, and it's based on a number of ISO standards, and it can be mapped, or it's directly mapped onto the GML exchange format, but it can also be mapped onto different exchange formats. And it has, in the new version, it adds really some key components for the digital twins, and one was the versioning module, and the other one was basically linking to sensor data, linking to time dynamic data that was basically also there. And finally, CityGML datasets are also very rich information sources for urban analytics and simulations, especially also for AI training. So if you look, for example, at Japan, at the models in Japan, you have basically, 20, even 30 million buildings which have been generated and are highly accurate. And so you could use this kind of information, for example, to train your neural networks to automatic object reconstruction and detection, for example. This is not really so much reflected in the computer vision domain yet. So I think they are probably not aware about these resources. So that's something that is also available. So thank you very much for your attention, and I'm also here for questions.
Thank you so much, Thomas. And Amit, if you'd like to come up, that would be fantastic. We've got a long minutes for any questions from the floor. If we can have our wonderful roving microphones again, that would be great. But while we get those, perhaps I've got a question for you. It's been really interesting to hear about the various technical solutions, but what would you say, each of you, what is the biggest challenge you have to getting those solutions adopted?
Actually, generating semantic models is expensive today because it cannot be solved completely automatically yet. This is true for BIM. So if anybody telling you scan to BIM automatically, that's not happening. I mean, you have supporting systems which can do that, but you cannot do that on a completely automatic way. And the same is true for at least for the higher levels of detail in CityGML. So with CityGML LOD2, we can now really have a full automation on that. But regarding level of detail 3, when it comes down to windows, doors, about the separation of each driving lane on the street, etc., it still requires a lot of manual work. So that means an investment. And that means, again, this investment is only being taken if you have a revenue for that. And that's still today an open issue. Yeah.
Great. So I hope there are some funders in the room who might have heard that. We need some more investment, please. Amit.
This is a good point. I think on non-technical side, I would give an example of data sharing. So data sharing across domains, there are two problems. One is slightly technical, which is the different levels of digital maturity. But I'll skip that for the time being and focus on non-technical, which is how to engage with the legal counsels from the respective divisions, because data sharing is in itself a big legal conundrum.
Yeah.
And I think that from a legal perspective, there is a challenge that we as engineer scientists sort of say, oh, okay, the legal counsel will sort it out. And I'm not blaming anyone. It really takes time and effort. Yeah. And it's massively complicated because no one wants to ultimately take the responsibility if things go wrong, right? So I think I would say legal data sharing aspects, if it's were to be non-technical.
Also a very, very fair comment. A bit of an unfair question, but and I haven't. Have you seen anyone do it particularly well in the legal sense? Is there anyone out there who's doing it well that we could, or are we still seeking that solution?
It's not like the ideal way, but I think the approach taken, at least in the Credo sense within the UK, was very practical and still difficult and still massively a challenging one. But I think the good thing about it is the project, first of all, hats off to the Credo team for getting the legal counsels in one room and not warring against each other, but then to also disseminate the templates. So what they have done is put the legal templates into the public domain so that other such projects could. So I think it's best to be practical, though. Absolutely. I now put my technical hat on, which is the lawyers might say this is easy to say that. So.
That's a fair comment. Thank you. Do we have any questions from the audience? I'm hoping we might. Wonderful.
About the availability of the data, will this new legislation from the European Union about high valuable data sets that they are will be free in, I think, in 2024 or 25, will that affect the open, and to which extent?
Maybe I can make a first answer on that. It already has an effect. For example, in Germany, we have the 16 state mapping agencies. So surveying and cadastre is basically done on the state level. And we have 16 states in Germany. That basically means 16 states have to develop their own idea how to do data sharing. And a couple of years ago, there was no data sharing, so it was all just selling the data, which just a few companies did. For example, energy providers, they basically bought this data. But now with this European regulation in place, it is expected that in the next 1 or 2 years, every of the 16 states in Germany will release all this data as open data. So it does not include property-related information, so who is the owner of a certain parcel, but at least the parcel boundaries, the parcel identifiers, etc., they will be there. Also the building information, the 3D building information. Now in Germany they're also measuring and providing very simplified representations of bridges. These will also be part of that, so that means this data is becoming open data. At the moment, I think we have 10 states which are offering and giving away the data. The beginning of this year, the state of Bavaria, where I'm in, it has basically flipped to this open data policy, but because of the pressure from the European Union. Otherwise, it wouldn't have happened.
I always give controversial answers, but I'll try to stay away from it and say it depends. It really, I think talking about Europe then, obviously Germany is an example. So we are looking at, sorry, my German is horrible, Wärmeplanung, so energy planning. And that, I think this has greatly helped, whether it's thanks to the Commission or not, I don't know, but the fact that they're doing it, this is brilliant because we can build the energy planning and benefit from that open data. In Singapore, we have found things are advanced but not as open. And in UK, there's sort of somewhere in between, but also quite generous when it comes to open data acceptance. So depending on where you are, it will influence the work. That answers your question.
Great. Any more questions out there? Fantastic.
question which maybe utilizes that the two of you are sitting there. I think the CityGML to me sounds it's very focused on city and city infrastructure, right? But then there is a lot of, how to say, specialized infrastructure providers like rail or electric power grids or cellular systems that also would have digital representation or digital twins. How would you interoperate and make use of that in both directions, so to say?
So first of all, CityGML is not intended as a replacement for these specialized data models. For example, in the electricity domain, you have the SIM data model, for example, to represent the energy networks. And however, the energy networks in SIM don't have a 3D geometry or something like that. So that is basically an idea how things can come together. We have in the past developed an extension for CityGML that's called Utility Networks Application Domain Extension, and we also mapped electrical power lines, but not just power lines, but also substations and these kind of things to concepts that could then be represented in 3D. And that has also been used in some projects where we investigated for cascading effects in the failure of these things. But in the end, it's more really, you can say, it's something like a common denominator that can be used to bring things together and make sure that you have a common understanding of things. So on the one hand side, the building data that is being maintained by the state mapping agencies is something that you can already use as an asset and really say, okay, this is already providing not just semantic data, but also some data that you could connect other information to. And then, of course, yeah, adding maybe additional data. So it can be done by extensions, but on the other side, I think if an energy provider wants to visualize his or her cables, something like that, I would simply say, take the CityGML data, bring it into your system, maybe make a conversion for a visualization format or something like that. That's completely fine. So in the end, I don't think we will have one centralized representation, but it depends what you want to do. Sometimes maybe sticking to this data model, bringing the other into that domain, or sometimes also taking the data and bringing it either to the BIM domain, for example, or to others. It's really, unfortunately, we will not have the situation that everything is being harmonized in one representation.
I think we take a very practitioner's and very practical view of the situation. What you have underlined is a super important problem. We incurred that in Credo, we incurred that in the other project on maritime smart port city as well. And the approach is, rather than waiting for standards to come up on how exactly to do data sharing, we can't wait for that. So this is where we go to the domain experts, and in case of rail, if they have a rail domain specific vocabulary or a schema, we then semantically enrich it and then connect it or map it with other ontologies. So it's kind of multiple domain ontologies talking to each other. Of course, you can say that then another expert comes in from another rail industry somewhere else and says, doesn't say literally, but means to say, I know better. And in that case, we map that to that ontology. And I think the whole approach is either you wait for a standard and exactly that tells you what to do, or as a practitioner, we take that leap and we just do something. Of course, the ontologies are never perfect. An ontologist in the room could come up and say, okay, you have just 10 concepts, but philosophically, I can think of the same problem and define it as 100 concepts. But I think using the ontologies in this case helps because you are fluid and you can update your knowledge as you learn more. So.
Thank you, really helpful. Any more questions from the floor? No. I have one more for you, I think. From a technical point of view for both of you, what practical advice would you give a city or a region thinking of creating a digital twin who hasn't done anything yet? Is there one thing that they should do before they start out in a technical way?
When you really say digital twin of a city, then of course I would say a digital model is part of it, so you should already think about that. But then again, don't start from scratch, look what you already have. So for example, if you have a cadastre where you have the building footprints already, that's a very good starting point to start with. then using maybe laser scan data or some other data that you can do to build up the 3D and to reconstruct the 3D shape. There are automated tools for that, commercial available tools, which do that very, very nicely. Or you can hire a company maybe doing that for you, so that's also something. But of course, digital twins are not just the 3D representation of the environment, so you also need to, first of all, think about the use case. I mean, it should not be simply saying we are now building up something. I think it should always be motivated, hopefully not by a single use case, but maybe by 3 important ones which are on your agenda in the city anyway. So that means you need to already have the decision that the city is going to spend money on it, because if you simply say we are creating this maybe as a demonstrator and something, it will not work out. So I think really real world problems, and that is then a good starting point, because that will also tell you what kind of analytical tools you will need, and also what further other kind of data you would to check. However, there's one thing that my personal opinion is you should have a look at thinking about a catalog system. So saying, okay, in the end, in my digital twin, we have all these different kinds of resources, some data here, some sensors there, some project relevant information here. And so the idea is maybe also have a catalog, building up a catalog, which then lists the stakeholders, lists the resources, and also interconnects them on the catalog level.
Wonderful. Amit, have you anything to add to that?
That's a fantastic answer. I would say the purpose is really important. What I mean by that is, if the purpose is to, especially if the city, and I'm just assuming let's say they haven't done anything in digitalization space, and there are very few cities or even none like that. But let's assume that. In that case, if the purpose is to show the benefit of digitalization, I would do something, even if not perfect, do something, add value and demonstrate. If it's a city that has already embraced digitization first and digitalization then, to a certain extent, I would pretty much send them to Bart, and he had this nice slide where he talked to, I think, 6 people from Singaporean ministry, which is, I think, a terrific effort, because I know how much effort it takes to talk to one. To get 6 on board, that'll be brilliant, because then you can have really a multi-objective function, and you can have that as a cost function where you want to minimize CO2, minimize OPEX, have the best things in terms of citizen well-being, and you can have those multiple objectives and then develop a connected digital twin. Of course, that is more resource intensive, which means money is a question. So it really depends on the purpose, whether it's to demonstrate something or to go, as Thomas said, really full throttle on a citywide benefit.
Thank you. That's amazing. Thank you so much, both Thomas and Amit, for your time. And you have a question, please.
So, regarding the knowledge graph you've been developing within the Credo project, is it continuously being developed, and is it any IP-related concern about sharing that with like the Swedish cohorts?
Excellent question. I didn't cover that, but spoiler alert, I think Mark, there will be, so Mark has just walked in, Mark will be covering that in his talk, so he'll discuss it more. We are moving towards, of course, other climate modes. So I presented flooding, but we are also going into extreme heat, etc. We are also bringing in more asset owners. So you saw the example of NHS as a healthcare system, but we're also talking to national highways and other asset owners, so that we can really build that connected digital twin with extra asset owners. So that was, I think, question 1. And question 2, as I said, at least CMCO strategies, if it's a public funded project, whether it's European Commission or UK government, we put everything in the public domain. So, and I think Credo is a fine example of that. We have shared everything from legal templates to the code is on GitHub, so it's as open as that. All the technical reports, all the papers published, peer-reviewed or otherwise, they're all in public domain. So if it's public funded, it needs to be out there. So we'll be more than happy to embrace with anyone. And I would say DT Hub, the Digital Twin Hub, is a great instrument for such collaborations. And John is somewhere.
Somewhere. There we go.
So John is, feel free to engage with us, and I would say more the merrier. It's connected, of course.
Wonderful. Thank you for the question and thank you for the answer. And thank you both, Thomas and Amit, for sharing your
Thank you.
keynote.
You're welcome. Thank you.
We've now got a 10 minutes break, maybe, for you to go from here to your next parallel session. They're up here. One's in the hall, one's in Tesla, one's in Pascal. So that's for an hour. Then there is half an hour coffee and networking and exhibition out in the main hall. Please be back here for 16:15. We've got our last two keynotes. We've got Steve Brown and Mark Enzer talking to the future and the future, which will be fascinating. So please make sure you're back here in time for 16:15 start and enjoy your parallel sessions. Thank you.